Now, I want to take the same sort of a story and we're going to roam into the 30, the environment, and I want to talk about a similar sort of a story around this. This is one of my favorite pictures. This is a couple of gentlemen. They're sitting on something that they found, and it's recent enough, I guess, that there were pictures available to be taken, so this is late 1800s. And what they're sitting on is a copper nugget. That was what was available when we first came into the United States and started looking for resources. And guess what? We ran out of nuggets like that. Those all got scooped out of the stream beds pretty quickly. And so that's okay. We went on to the smaller nuggets. That's what you do, right? You start with the good stuff and you go to the slightly smaller stuff, and we ran out of those. And that's okay. We went to copper ores. This is beautiful stuff here at about 10%, bright green band. It's lovely stuff. And we kind of ran out of that. And so in the United States now, this is what our largest copper mine looks like. This is the Bingham Canyon mine. It's 3/4 of a mile deep, 2.5 miles across, and it used to be a mountain. The copper ore grade that comes out of this mine is 0.2%. And we're not doing that because we like to give our engineers challenges, right? We're doing this because that's the stuff that's left. And instead of thinking about 0.2% and how much does that mean we have to pay for copper, I want you to think about the energy required. You know, mentally put on a backpack, load it up with some 0.2% ore, and start walking up that hill. Right? Just think about the energy embodied in getting that stuff from the bottom to the top. And once it's up there, you still have to process, crush, leach, refine, smelt 500 pounds of earth to get 1 pound of copper. So this is where we're at after only 150 years of industrialization of our economy. Just 150 years, from giant nuggets and stream beds to giant holes in the ground to get this very minor stuff out. So the question becomes, well, what does the next 150 years look like? Again, this requires a huge amount of energy to prosecute. But the story in copper I've told you, we could go to many other things. So here's a list of elements. This says how many years of reserves globally are left in these various elements if we continue to grow their production at 2% a year. Look at the stuff on the left. There's 10 years. 10 years of silver left, maybe. 10 years of, maybe 15 years of antimony. Maybe 15 years of gold. That's what we know about. Now, it's possible, maybe there'll be some other huge finds, but what we know about reserves at this point in time, they've been reasonably well mapped, and we can actually look through the windshield of the car we're driving and see the end of certain key minerals. But by the time we're down to the last few decades of materials, we are down to the stuff that represents giant holes with very dilute mineral and ore concentrations. So that's part of the story. And so what I want you to think about then is when it comes to resources, think about generalized, this is a resource extraction profile, the big green one. We find all the great big nuggets, and then we find the smaller nuggets, then we're down to the 10% ore grade, and then we're down to the hard stuff. And guess what? We'll find that we will get more and more and more stuff out of the ground, and then we'll get less and less and less. But the thing about that story is not the less and less that's really critical, it's that the amount of energy that's required to get that stuff out of the ground, because it's farther, deeper, more dilute, doesn't go up linearly. It vaults up enormously. It's not linear. And by extension, that would mean that the cost would also be going up quite a lot. So the question before us is we look at the potential peak of oil and we ask ourselves, what's connected to that? How many things are connected to that? And that is connected to literally everything. We could say a peak in oil might well represent a peak in just about any other key mineral resource that we can think about. If not now, maybe in 10 years. If not then, in 20 years. I'm back to my statement. The next 20 years are going to be completely unlike the last 20 years. Because now, in this next 20 years, I can reasonably foresee a period where we're going to be asking the question, are we going to be dragging that copper up out of the ground, or are we going to be using that oil for something else? We might have to start making that trade-off. And that's something that we've not had a lot of experience with yet as a culture, or as a society globally.